The first question that we should be thinking about, this is a class on global climate change, is where is the climate, right? And the climate is really a function of the atmosphere. So that means we need to start talking about the atmosphere. The atmosphere. Okay, so what's the atmosphere made out of? Well, it turns out the atmosphere is complicated. The atmosphere is kind of structured in layers. And if we were to think about, here is the surface of the Earth, we recognize various layers. This is not drawn to scale, and we're really only going to be talking about one, but I did want to mention, what these are. So if you were to leave, Earth in a rocket ship or some magical suit that you had, and you were to be heading out to space, there's no hard boundary where you hit space. The molecules that make up the atmosphere, the gases, just become further and further and further apart until eventually you're in space, right? So it's kind of this gradation. But at the top of that gradation, all of these different layers are kind of sub-spheres of the atmosphere. Sphere because they're spherical, right? They go around Earth. So starting from the outside, what you could call kind of the farthest reaches of planet Earth, the outer sphere is the exosphere, thermosphere, mesosphere, stratosphere. We're not going to talk about those very much. Super interesting if you're in an atmospheric class. What we're going to focus on is this layer down here that we live in called the troposphere. Tropo. It's a prefix that means mixing. So this is essentially where all of the weather happens. The stratosphere is really layered, and so on. So for most of this class, we're going to be focusing on things that are happening in the troposphere. So if we were to take a sample of the troposphere, what we would find is that the gases that make up the troposphere, there actually aren't very many of them. So most of the atmosphere is this gas nitrogen. It's bonded with itself, so we call it N2. So that makes up about 78% of the troposphere. About 21% is another gas that you're familiar with, O2, oxygen. Oxygen bonded with itself. And then things drop off pretty quickly. So mostly the atmosphere is nitrogen with a bunch of oxygen. There's about 1% a noble gas or an inert gas called argon. And then this is really where things are going to get important. 0.04% CO2. That gas is something that we're going to talk about a lot in this class. CO2 is different than the rest of these gases. If you look at these gases, N2, O2, argon, and CO2, well, nitrogen is what we call a monatomic molecule, one atom. Oxygen, monatomic molecule, just oxygen bonded with itself. Argon doesn't care. It's just not bonded with anything. It's inert. But this guy is a polyatomic molecule, CO2. 1 part carbon, 2 parts oxygen. There are 3 atoms in that molecule, and those 3 atoms are 2 different elements. That's going to become a really big deal. The next thing that we're going to talk about is radiation. Radiation, the type of radiation you talk about in your physics class, it just means energy transfer. And radiation is the type of energy where the energy is in the form of particles or waves that are traveling through. And we use the term space, but it's super confusing because space, think about outer space. Space kind of meaning a vacuum, like open space. So this is energy that travels across a vacuum. We use the term space. Super confusing. Sorry about that. And there's lots of different types of radiation. The radiation that we're talking about is usually abbreviated EM, meaning electromagnetic radiation. And you can take a look here. You've actually probably heard of some of this. This is the electromagnetic radiation spectrum. And you can notice that each different type of wave is shown as a wavelength, right? So you've got longer wavelength, and as you progress kind of across the electromagnetic spectrum, the wavelengths get smaller and smaller and smaller. And actually you cross into what we call the visible spectrum. So that's radiation that's perceived by us as visible light, and then beyond that you go into infrared and so on, right, all the way up to, you know, really, really, really shortwave radiation. And so the heat of something determines where it's going to be emitting radiation. So if you think about taking you kind of take a piece of metal, right, a metal rod, and you stick it into the fire, or a fire, let's say you're camping, for 3 seconds. You pull it out, and you touch that rod, it's going to be hot, right? It's going to be emitting radiation, because everything that has heat that isn't absolute zero, which is negative 274 degrees Celsius, I think, close to that. You can touch that rod, and it's going to be emitting long wave radiation in the form of infrared, in the form of heat. So you'll be able to feel the heat. But if you do the experiment again and you put the piece of metal in there longer, it's going to heat up warmer, and when you pull it out, it's going to be emitting shorter wave, because again, it's a function of the heat, and it might be emitting shortwave radiation in the realm of visible light, meaning the piece of metal is going to be glowing. This should sound familiar, right? Like red hot. And it starts with red, and then it starts emitting all the colors, so you get this kind of white hot. So the sun is what gives us radiation. And we can think about this radiation as coming from the sun. Again, what does this all mean? This is why the Earth is not a frozen waste of space, right? So the temperature in space was 3 degrees, so it's about negative 270 degrees Celsius. It's really cold in space. But this radiation comes from the sun, travels, you know, through space, it's in the form of radiation, and hits Earth. And one of the interesting things that happens is that, well, the Earth is a sphere, believe it or not, right? Tell your flat Earth friends. So if we looked at 2 different places on Earth, because the Earth is a sphere, and we thought about, here's an area closer to the equator. So we can think about how much radiation is absorbed in that part of the Earth. And if we took the same amount of area in one of the polar regions, South or North Pole, doesn't matter, and we thought about how much energy is absorbed in that same area, it's far less energy, which fundamentally, it's cold in the polar areas, and it's warm in the equatorial areas. That's a first good lesson into a climate class, right? Why there's kind of warm weather here and cold weather here. It's largely a function of the Earth being round. So again, go after your flat earther friends.